2.1 Arithmetic sequences. We're going to write a formula for the general term, the nth term of the arithmetic sequence below, then use the formula for a subscript n to find the 20th term of the sequence. Okay, so the general form is something like an is equal to a1 plus n minus 1 times d. Okay, so what they're saying is they want the value of the 20th term. Well, first we're going to make a general one, right? So in our case, a1 is the first term right here. So we know a1 is 1. So we simply plug in a1 plus n minus 1. Now the difference, we need to know the difference. The difference is the difference between these two, right? So you take, for instance, 7 minus 1 equals 6. So this is between this one and this one. We can do the same thing over here. So it'd be 13 minus 7 equals 6. And you can do this with any of these two terms, right? The difference between 19 minus 13 is 6. So the difference between all this is exactly what it sounds like. It's the difference between two terms right next to each other like this, right? Okay, so we know d is equal to 6. So we end up with this formula. Now they ask for the 20th one of the sequence, so we are simply going to plug in n is equal to 20 and use our formula to get an answer. So we say 1 plus. Now 20 minus 1 is 19. Alright, so then you have the 20. And then we say 19 times 6, which is 114. And then 114 plus 1 is 115. Move on to the next one. Find the sum of the first 30 terms of the sequence. All right, so you have n is equal to n divided by 2 multiplied by the first term plus the last term. Okay, so so let's see the sum of the first 30 terms. So we know n is 30, excuse me. And then we want a1, so we want to find the first term of the sequence. Well, it's actually listed right here, so that's the a1 terms right there. So we know a1 is 5. Now they want to know the sum of the first 30 terms in the sequence. Well, we need to find a30. That's the question. What's the last term in the sequence? Because it's going to go right here in the formula. Okay, so we found the first two pieces. We have the n. All right, our n was 30. We have our first one. That was 5, but we don't know the 30th term of the sequence. But we do have a formula for that, which is the previous formula that we used, right? So this one right here, we're going to use this one right there to find the 30th term. Okay, so let's find the 30th term. So we have an equals the first one plus n minus 1 times d, the difference. That's the general form. So we are going to use the first one, which is 5. Plus, in this case it's 30, because we're trying to find the 30th. I actually should have put 30 here. Okay, and it's 30 minus 1 times d, and we find the difference, right? Just like we did before. So let's say we say 8 minus 5 is 3. Then we could, if we wanted to confirm that, we could say 11 minus 8 is 3. 14 minus 11 is 3. So the difference between any two of these is 3. Just constantly adding 3. Okay, so we know the difference is 3. So we're looking for the 30th term. So it's 5 plus 30 minus 1, which is 29, times 3. So then we say 5 plus 29 times 3, which is 87. And 87 plus 5 is 92. All right, so we have our 30th term, 92. All right. So we're going to use this formula now right here. Okay, so if Sn n over 2 times a1 plus 30 in our case, but, well, the general one is n. So specifically to ours, we're looking for the 30th, so it's going to be 30 divided by 2. Our first term, way over here, 5, plus our last term here is going to be the 92. Okay, so then we just do some calculations. Alright, so 30 divided by 2 is 15. 5 plus 92 is 97. And that's 1,455. Alright, so we want to find the sum of the first 50 terms of the arithmetic sequence below. Okay, so first, we need the same information that we needed for the previous one. So again, the general formula. One good way to memorize these is every time before you use a general formula, just write it down. And after you do this enough times, you'll have memorized it. So we need n, which is great because they gave it to us right there. That's our n. So n is equal to 50. We need a1. Fair enough. That's a1. a1 is equal to negative 17. Right? So we got that. But just like the previous one, we don't know what our 50th term is. So we need to find the 50th term. And the 50th term is the first term plus n minus 1 times the difference, d. So we plug in what we know. So the first term within the sequence is going to be a negative 17. Then we want 50th term, so we're going to add plus 50 minus 1 times the difference. Okay, well, how do we find the difference? Well, you take the later one. For instance, right here we have negative 11 minus negative 17, which is negative 11 plus 17, which is plus 6. So from here to there was plus 6. Now this is just going to continue. We could verify it if we wanted to, but it would just verify it. I'll do one more just to make sure, right? So negative 5 minus negative 11 is the same as negative 5 plus 11, which would give me a positive 6. It just verified it. And again, you can even do it another one because it has a 1. 1 minus negative 5 is the same as 1 plus 5, which is 6. So regardless, it works out. They all end up being 6. So we know the difference is 6. So then we say an is equal to negative 17 plus 50 minus 1, which is 49 times 6. All right, so we have negative 17 plus 49 times 6. So it'll be 294. And I shouldn't be using in there. That actually technically should be a 50. Okay. Okay, so negative 17 plus 294 would give me 277. So we want to find the sum of the first 130 positive even integers. Okay, now this might help to actually write out the first even positive integers. So even positive integers, things like 2, 4, 6, 8, ... And so that's the pattern. And the reason this is important is because the difference between even integers is 2, right? So 2, 4, 6, 8. The difference between every one of these is 2. Keeps increasing by 2, right? We're going to find the sum of the first 130 positive even integers. So the summation is Sn is equal to 1/2 the first term plus the last term. So we need to find n. And the n here is 130. We need to find the first term. First term here is 2. We need to find the last term. And the last term we need to find out. And the way we find the last term is we use the equation an is equal to a1 plus n minus 1 times d. In this case, we're looking for 130. So the first term is 1 plus n, which is 130, minus 1, times d, d being 2. So that gives me 2 plus 130 minus 1 is 129 times 2. That gives me 2 plus 129 times 2 is 258. And 258 plus 2 is 260. 260. All right. So we know the last term is 260. Okay, so now we get to plug it in here. So that is, now we're looking for s to the 130th, which gives me 130 over 2 times 2 plus 260, which gives me 65 times 2 plus 260 is 262, and 65 times 262 is 17,030. There you go. All right, so a company A pays $26,000 yearly with raises of $1,400 per year. Company B pays $28,000 yearly with raises of $800 per year. Which company will pay more in year 10? How much more? Now, I think when they say the company will pay more in year 10, I think they just want to know the 10th year. Now, they could slightly reword this to make it seem like the summation or in total, but I'm saying because it says which company will pay more in year 10 instead of saying in 10 years. That would be slightly different. So what we're really looking for here is we're looking for this. All right, so how much do they make in nth year? Well, that'd be the first year plus it would be n minus 1 times d, the difference. Okay, so company 1. So company A in this case. So we're saying company A. I'm going to do company A over here. Okay, so we're going to say A in this case, they're looking for the 10th year. So we'll say that the 10th year, A10 is equal to the first one, which is 26,000 plus n. So we're looking at 10 minus 1 times the difference, which is 1,400. Okay, so 26,000 plus 9, right? 10 minus 1 is 9 times 1,400, which is 26,000. But 9 times 1,400 is 12,600. So 26,000 plus 12,600 is 38,600. So that's how much they get paid the 10th year in the first case. That's not the same as the total, though. Total pay would be different. So let's move on to company B. So company B is going to use the same formula, right? It's going to take the first year plus the number of years minus 1 in this case, so 10 minus 1, which is 9, times the amount that they get paid increase per year. So in this case, it is 8. The difference is 800. So we say we're using the 10th. So I should have plugged that in earlier, but I didn't. So the first year in this case, we get paid 28,000. And then we are going to be adding 9 times 800. So 9 times 800 is 7,200. And we started off with 28,000. So we know we have 28,000 plus 7,200, which will be 35,200 on the 10th year. So company A pays $38,600 the last year. Company B pays $35,200 the last year. So you're going to end up getting paid more the 10th year in the first company, company A, than the second company, company B. Now, that doesn't necessarily mean you want to do that because you could do total pay. Since this one starts off, you still might end up with total pay over a 10-year period with this one rather than this one over here. So total pay is different altogether.